Hi, in this particular video, I just want to review the test you did on financial mathematics. The test was specifically focused at the calculation of NPVs and the internal rates of return. So let's look at the two questions that you had. The first question was two projects P and Q have the following cash flows. Using the net present value criteria, determine which project is most profitable if the discount rate of 6% and 8% is used, and then estimate the internal rates of return. Now, many of you know how to calculate the net PVs and the internal rate of return, but the mistakes I noticed was some you were just focusing on calculating net PVs and the internal rate of return for one project, and you end there, which is not good enough. You have to learn to maximize points on questions like this. So let me show you how this can be done. So on the solution, let's start with our project P, probably. Let's start with project P. So we bring down project P at 6%. What will be the NPV? Project P at 6%, what will be NPV? Easier way of calculating NPVs is always using tables. So you insert a table. That table should have 4 columns on it. The number of rows depends on the number of years. So what are we dealing with in the question? About 5 years. So make it 6 rows. Okay, so we have that table. So on your first part, that's your year, followed by your cash flow, followed by the discounting factor. This is at 6%. And then you have the PV on the left side, where you're going to get the net PV. Years, you start with year 0, then year 1, year 2, year 3, year 4. We should add one more row for year 5. So insert row below, that's for our year 5. According to the question, we have 5 years. So what are the cash flows? The cash flows are for year 0, it's a negative 420 for project P, so we bring it there. For year 1, it's a negative 5. So copy that, paste it there. Those are the cash flows. For year 2, it's 122. Copy it from there, paste it there. For year 3, it's 130. Write it down. That. For year 4, it's 148. 148. Done. For year 5, it's 150. 150. So easy. 150. Then DF at 6%, you go to the present value table to just pick these values. Column 6%. Column 6%. Of course, for year 0, it's going to be 1.00, but for year 1, 0.943, that's a 6% from the table. For year 2, that's a 0.890. The next one is 0.840. The next one is 0.792. The last one is 0.747. 0.747. Where am I getting all these values? Just from the table, present value tables. Get those values. Then finally begin to multiply. You have a negative 420,000. That's multiplied by 1. Negative 5 multiplied by 0.943. That is going to be a negative 4715. 4715. Then 122 multiplied by 0.890, that's going to be 108,580. 108,580. 130 multiplied by 0.84, that's going to be 109,200. 109,200. The next one is going to be 117 to 16. 117 to 16. The next one is going to be 112,050. So when you calculate your NPV, how much should be our NPV? NPV value will be equals to, of course, add the positive values first and then subtract the negative values. When you do that, you must have 22,331. So 22,331. That should be your NPV for this particular project at 6%. What will be the NPV of project P at 8%? So project P at 8%. So let's just borrow that. So at 8%, our DF is going to be different. We have to look at column 8% from the table. Then our values here, except for the first one, our values here will also change, and our NPV value will be different. So the cash flows are the same. So at 8%, what will be the DF? So go to the present value table and get the values at 8%, column 8%. You should have 0.926. The next one is 0.857. The next one is 0.794. The next one is 0.735. Next is 0.681. So 681. Those are the NPVs. Then you begin to multiply. Negative 420,000 by 1. That's negative 420,000. Then you have negative 5 multiplied by 0.926. That is going to be negative 4,680. Negative 4,680. Negative 4,630. Okay, so 122 by 0.857, that will be 104. 104,554. The next one will be 103,220. The next one will be 108,780. The last one will be 102,150. So what will be the NPV? Add the positive values minus the negative values. Your net should be a negative 5,926. Negative 5,926. So that's the PV. So at 6%, project P is profitable. At 8%, project P is not profitable. Let's calculate the NPVs for project Q. For project Q, so let's bring it down there. Project Q. So project Q at 6%. Project Q at 6%. Let's borrow this table. Project Q at 6%. Of course, the cash flows for project Q will be different. When you get the discounting factors from the table at 6%, they'll be the same. The PVs will be different. So let's bring in the cash flows for project Q. Cash flows for project Q. The cash flows, the first one is a negative 95,000. The next here is a negative 10,000. Bring it down there. The next is a negative 120. Negative 120. Copy down. The next is a 200,000 cash flow, net cash flow, followed by 110,000 net cash flow. The last one is a negative 50,000. It's a loss of 50,000 in year 5 for Project Q. So let's bring down that one. So we have all the cash flows, we have the DFs, present value, just multiply negative 95,000 by 1, that is going to be negative 95,000. So minus 95,000. That one multiplied by that is a negative, that is a negative 9,430. So 9,430. The third one is also a negative. Multiply that, that's a negative 106, negative 106, 800. The next one is a positive value, 168,000. When you multiply that set, you should get 87,120. Finally, it's going to be a negative 50,000 by 0.747. That's going to be 37,350. 37,350. So calculate the net. We'll have the net PV of so if you net the positive values minus the negative values plus that one, the negative values, you should get a positive 6,540. 6,540. It's supposed to be there. 6,540. So Project Q at 6%, it's profitable. What about Project Q at 8%? So borrow that table, duplicate it down there. So now we are talking about Project Q at 8%. So these are going to change. We are going to our NPV table at 8%. So our PVs will be different and also our net PV will be different. So at 8%, what are the net PVs? Look at Project P at 8%. So what we are going to have from the table are the same values at 8%. So same values at 8%, bring them down there. We have those values. Let's calculate the PVs. That's going to be a minus 95,000. Multiply there, it's going to be 9 to 60 negative 9 to 60. The next one is also a negative 102 102,840. 102,840. The next one, 200 by that, is going to be 158,800. Positive value, 158,800. The next one is 80,50. And the last one, when you multiply, you should get 34050. Okay, so that's a negative as well. Negative. Please be mindful of the negative values. So positive values minus the negative values, you should get your NPV of minus 1,500. So NPV at 8% for project Q shows a loss. So at 6%, project Q is yielding 6,540. At 6%, project P is yielding 22,310. So P is better at 6%. So that's your conclusion now. As part of your conclusion. So at 6%, project P is beta. Why do we say beta? It's because project P is yielding a net PV of 22. So project P is yielding that at 6%. Let's bring down those details. So project P is yielding that. That's what we are saying, it's beta. What about the project Q? At 6%, project Q is yielding that much. Project Q at 6%, project Q is yielding that much. So project Q at 6%, NPV is that. Project P at 6%, NPV is that. So P is beta. Now at 8%, at 8%, it's actually project Q that has got a lesser loss. At 8%, all the projects are making losses, except that the loss for project Q is lower than the loss for project P. Let's bring in these losses. So project Q loss is that. That's the project Q loss at 8%. What's the project P's loss at 8%? We calculated it was that at 8%. That was the project P's loss at 8%. So you conclude in this case Q will be much better. The loss there is much lower than the loss for project P. So that's all you needed to do. Let's calculate the internal rates of return. Internal rates of return. So let's have the formula for the internal rate of return. This is the part B of the question. Internal rate of return formula can be written as follows. Let me just bring down that formula. So the internal rate of return is equals to A% plus open brackets A divided by A minus B. Then we have B rate, B% minus A%, cross brackets, and close the other brackets. Everything you calculate there must end up as a percentage. So that's the formula. Now in this formula, the A rate is the rate that gives us an NPV that is positive, and that NPV that is positive, that's A. The B rate is the rate that gives us the NPV negative, and that NPV negative is B. So let's get our data. We have been given that project P 6% gave us a positive NPV. Project P 8% gave us a negative NPV. So that's the data that we have. So what will be the internal rate of return for project P? What will be the internal rate of return for project P? So it's the IRR for project P. Let's substitute in our formula. The rate that is giving us a positive NPV is a 6%, so that rate is 6%, and the NPV we are having from a 6% is 22331. 22331, and that is what should be there, 22331. The B rate is the rate that is giving us a negative NPV, that's 80%. A rate, of course, that's 6%, and the NPV for B is a negative value, which is a minus 5926, like that. So what happens here, when you multiply everything in the brackets, you should have 22331 plus negative multiplied by negative will be a plus that. So 22331 divided by the sum of the denominator there, and then multiplied by 2, which is 8 minus 6 equals to 2. So multiply by 2, what you should have, there should be, let's do this, showing the full steps there. So when you had what is below there, let's do that. When you had 22331 plus 592, you must get 28257, right? So then 8% minus that, you must have 2% here. That should be 2%. So what will be your final answer? What will be your final answer? There was a 6%. So you will say 22331 divided by 28257 multiplied by 2, then plus 6. That should give you 7.58%. So that's the internal rate of return for project P. Let's get the internal rate of return for project Q. So IRR for project Q. Internal rate of return for project Q. What do we have for project Q? Project Q at 6%, we had that. Project Q at 8%, we had this. That's a project Q at 80%. So what will be the internal rate of return? internal rate of return, that substitute, that is going to be a 6%. That is going to be 6,540, and that is going to be 6,540 minus the NPV at 8%, which is a minus 500. Then there we are going to have our 8% minus 6%. So what we have, all right, so this denominator is going to result in a sum, because negative multiplied by negative, that's a positive. So 6,540 plus 1,500 plus 1,500, you should get 8040. So you are going to have that divided by 8040, 8040, like that. Then subtract 6 minus 8, that should be 2%. So multiply that, that should be in brackets. So multiply, what will be the internal rate of return for this project? The internal rate of return is going to be 7.63%. So which one is better? Project P must have a return of 7,580 to be acceptable as profitable, and project Q must have 7.63. So which one requires a higher return? Which one requires a higher return? Of course, project P requires a higher return. So we need the higher return in terms of profitability for projects. So that's done for the question. Thank you very much for watching.